So we have two functions, a radical and a linear. So state the domain of f of x, state the domain of g of x. Okay, so I'm going to kind of test you a little bit. I want you to record the domain of f of x and g of x. Okay, I'll give you a minute or two. So domain all possible x values. Okay, who wants to be brave? What's the domain of f of x?
X such that x has to be greater than or equal to 2, or x is known to all the numbers.
Nice, that's very fancy.
2, infinity.
Or 2 comma infinity. Or 2 comma infinity, right? Square, round. Why is that? They're both correct. Why is it that x has to be greater than or equal to 2?
Because there's a shift.
It's positive.
To make sure that the piece under the radical sign, the radicand, is positive, because we can't have negative square roots. Good. Okay, what's the domain of g of x? All real numbers, right? Or we could say x such that x is all real numbers, right? Because it's a linear function, right? There's no boundaries, there's no bounds on domain or range for linear. Good, okay. Given that m of x is f of x plus g of x, write an explicit equation for m of x. They're just saying add together and simplify. So m of x would be equal to, well, f of x plus g of x. So that would be the root of x minus 2 plus x plus 1. Okay, that's going to be a really weird, you could try that in Desmos later if you wanted to. It's kind of going to resemble, I think, a radical, but a little stranger, not quite radical shape. Given that p of x is f times g, write a statement for that. Oh, sorry, and then determine its domain. Okay, that might be a bit tricky, right? But this is where it's hard to visualize, right, in our heads what the new domain would look like. So this is where I'm going to give you your first kind of new little note. When combining functions, the new domain, so the domain of the combined functions will be the set of numbers that the original functions had in common. Okay, so whatever the old domains were, you look at the old domains and you just look at the domains of the two original functions and you look at only the parts of the domains that they had in common. So with that new piece of info, even though we don't really know what this guy looks like, because without the x we would know, right? But with the x in there, it kind of throws things off. So what will the new domain?
Wouldn't it just be the domain of x?
Correct. And why?
Because it's the only thing that has in common.
Yeah, so therefore, domain of, probably erase this because I'm kind of running into my next question. So as Eduardo said, the domain of, what was it? Yeah, m of x is x greater than equal to 2, right? Or 2 infinity. Now the reason is, if you think about it, it's always going to be the smallest domain, right? It's usually what they have in common. So my first, if I think of this on the number line, here's my 0, here's my 2. This is the domain of f of x, right? It starts at 2, and it goes forward, right? So this is f of x. And g of x is everything, right? G of x is all real numbers. That's the domain. So the only piece they have in common is right from here to here, right? So that's what the domain of the new function and the new function will be as well. That's all we're saying. So even if you don't really know what the function will look like, you'll know what the domain is. Okay, so that was A, that was B, sorry. Okay, I'll move over here for C. Okay, C, let's do P of x then. P of x will be f of x times g of x. So that's going to be root of x minus 2 times x plus 1. Right, so see what you get there. Let's see if I can easily call up, get this function going. I can take a look at it. Anyone want to take a guess what this guy looks like? Looks really... Okay, so what do we get here? P of x will be equal to, when I multiply radical and another term, I'm going to get x times root x minus 2, right? And then I'll get plus another x minus 2. Then, I guess that's it, right? And I can't combine these really. The only way I could combine them would be factor back. So this is a very strange looking function. Not one that you would have to graph in grade 12. But once again, the domain of P of x, well, again, it's just going to be whatever they have in common, right? 2 to infinity. The domains of the original functions haven't changed, right? So that's going to be what the domain is here. And I have a picture. I can slide this over. I have to do this extension thing. P.
So the domain, no matter what, like, how you combine it, whether it be addition, subtraction,
Yeah.
division, will always be
Yeah.
common.
What they have in common.
Okay.
So let's see if I can move there. I hope I didn't lose my other screen now. This is it. It's weird, eh? It just keeps going straight up. Now, it does start at 2, it's just because the scale is so, right? So it starts at 2 and goes to infinity. Okay? All right, so with that one, let's go back. See if I can get my screen back. There, good. Okay, so let's try this one. Or optional, and the word explicit equation just means the new equation. Use graphing technology. So I showed you what C looked like. You could play around at home and see what B looked like. Okay, let's try this one. I'm going to give you example 2. I want you to do A and B for example 2. State the domain of f of x of the originals, and then find the division statement. So it's going to be rational, and find the domain of the new created function. Yeah.
And I'm going to be asking for range, right? Sample range?
Yeah, that's if you use graphing technology. That's if you put it into a graph.
Okay.
Then they'll only ever ask you for domain because ranges are too difficult to do without graphing technology. So the only way I would ask you for range is if I actually asked you to graph it. Okay, but that's using graphing technology, so you have to use decimals or something like that. Yeah. Which we can't use in a test or exam, so that's why it's optional. Okay, have we come to a, what's the domain of f of x? So I hear a minus infinity 0. Agree? I do too. What does this graph look like? This is a radical, right? It's basically the radical graph, but flipped over the y-axis, right? So it's this guy. Agreed? Yeah, so y equals negative root x, so it's negative infinity 0. Perfect. Domain of g of x, this is our old friend of quadratic equation, right? Quadratic equation, what does this guy look like? To positive infinity, right? That's how all quadratics are. And how would you describe this quadratic? It's got a transformation, right? It's shifted 2 to the right, agreed? So it's shifted over here, so sure enough, that's it. Okay, so if you think of it that way, what's the domain that they have in common? The- yeah, it's just it's the smaller package, right? So the domain of, let's just write this, the domain of, oh, I didn't give a FG, let's call this H. Domain of h of x, it would be equal to, again, negative infinity just to 0. Okay? And h of x would be, I guess, the statement for h of x would be root negative x all over x plus 2 all squared. And you wouldn't be asked to graph this, right, unless you had access to technology. Okay. Yeah. What would the non-permissible be? You could, but what would the non-permissible value be here? Let's see, non-permissible value. Let's see, it can, negative 2 plus 2, yeah, that's about it, right? X can equal negative 2 for this bottom one, right? It's actually, let's see. That's true, right? Yeah. The new domain, you're right, Carlos, or Carl, what do I always, x can't equal negative 2, right? Let's take a look at the graph, because I have it here. So what do you see here? At negative 2. So we got to revise our statements, right? This statement here. Let's put a little asterisk. That's a really good unless we have a division statement with a non-permissible value, right? So when it involves division, we're just going to have to identify the non-permissible value. Thanks, Carl. And that would only happen with our rationals, right, with our division statement. Okay, let's see what's on the next page. This is a little, let's finish these last two, and then I'll let you guys, you can start with, like I say, I think I'll have an assessment for you tomorrow, an assessment assignment. Consider the function m of x. Write equations for 3 functions, or expressions for 3 functions, f, g, and n, so that they all add up to be m of x. Okay? Now, there's more than one answer for this, one possible answer, so come up with a possible answer. So here's m of x. We want 3 functions, f, g, and n, so that all 3 functions will add up to be 2x squared plus 3x minus 7. There's more than one answer, by the way, right? There's lots of answers. There's infinite answers, actually. And there's an easy way to do it. There's a super easy way, right? Does anyone have answers for me? What did you say, Adam?
Just 2x squared, jeez.
Yeah, that's the cheater's way. Well, it's not the cheater's way. I guess it's the smart way of doing it, right? You could say, okay, well, there's 3 terms. They want 3 it would be harder if I just gave you 2 statements, right? If I said you could. So you could say, okay, well, if f of x equals 2x squared, let's say g of x equals 3x, and n of x equals negative 7, then m of x would equal 2x squared plus 3x minus 7, right? That would be super easy. Did anyone think of a more original way to do it? No? You could say like this, you could be a little more creative. You could say, let's say f of x, I could say f of x is 4x squared plus 1. And I could say g of x is negative 2x squared plus 3x. Agreed? And then I could say n of x is, I have to get from a plus 1 to a negative 7, so I guess it has to be negative 8. Right? Like, you could play like that. Then what have I created here? I've created another m of x. It's going to be 4x squared plus 1 minus 2x squared plus 3x minus 8, and that's all going to even out to 2x squared plus 3x. Positive 1 minus 8 gives me my negative 7. Okay? That's a little more creative, but honestly, this is probably, it's definitely the most efficient way to do it, right? How about this one? Write equations for 2 functions, only f and g. This time you can only use f and g. 2 statements. 2 statements that will, when you subtract f minus g, they end up equaling this. So that's going to be a little harder. Hi, Adam. Okay, did anyone create f of x? I need an f of x and a g of x. So then when I subtract them, I end up with 2x squared plus 3x minus 7. You want to share anything with me? No? Neville, did you get enough of x?
I did not know if it's right, but 2x squared plus 3x. And then g of x is just 7.
Yeah, that would. So that equals that, right? Did anyone have anything different? No? No? Okay. All right, let's try this last one. Consider the function p of x is x squared minus 2x minus 15. Write two equations for functions so that they multiply out to give you p of x. Okay? So p of x equals two functions multiplied together, right? Here's my answer, x squared minus 2x minus 15 equals, you guys have seen this so many times before, right? It's just factoring. Now this time you don't really have a choice, do you? Like there aren't infinite answers. As a matter of fact, I think there's only one answer. So what's your answer? X minus 5, right? Yeah, so this time there aren't infinite, just because division and multiplication, they're a little tighter, right? This shouldn't really be b, it should be a whole different example. So let's try this last one. Given that q is x plus 3, write two functions f and g so that, okay, so this time it's a division statement, so q equals f over g. So q is x plus 3. Okay, come up, and you can't use this same one. No.
Why not?
Because I said so. Come up with two other functions. It's easy. Just come up with another binomial and throw it on the bottom. Throw any binomial on the bottom. This section is more like, the math isn't hard. It's actually just creating those links, right? Those connections that you've had before, and learning some new symbols, right? Learning more math language, really. That's what it is. Ryan, come up with, give me a binomial. What binomial did you put in your denominator? You want to do an x plus 3? Another one? What did you put on your bottom, in the bottom, Brian? Come up with one. Okay, so then what's my top going to be? It's got to be, this times this has got to be x squared plus 6x plus 9, right? So therefore, that's what we're calling f of x. That's what we're calling g of x, right? Are there other answers? Of course there are, right? If you guys would have been a little more playful today, could be, I mean, you could even have x squared plus, 100x, but you could have put an x minus 1 on the bottom. Then your top is going to be what? X squared plus 3 minus 1 would be positive 2x minus 3, right? You're just playing with functions, right? So when you're doing your division of functions, if you get nice ones to work with, it becomes almost like a factoring or deconstruction, right? Okay, we'll leave it there today. If you have not finished what I assigned in the textbook, finish it. If that's all you want to do today, that's fine. If you're looking for a bit more math homework, you can start looking at chapter 4 test. And the only thing is, when you see the word graph, like on number 7, just realize that they've used a graphing program. So you could use a graphing program to graph these and check your answers in the back if you want. And we'll keep working through the examples book, and then we'll get to some graphing tomorrow, like graphing that we can actually do. Well, it was a very short topic, right? Wouldn't you agree?
Yeah, when do you think you're gonna put the test, the quiz on?
I don't know. Tuesday?
Tuesday?
How does that sound to you?
Tuesday? Oh, that's too cold.
What does Tuesday look like
Next
to
week,
you,
Friday.
Abby? No!
Yeah, next week, Friday.
Cause I won't, because I won't show up on Wednesday, I have to study for my internalism Thursday. Yeah. I realize I need time,
What about Tuesday?
so the fast.
Well, we're pretty much, we only have one more little thing to do.
Okay,
We'll see.
alright.
I might rethink a test on this unit, maybe I'll just give you a